And this is the new video on our Indian Forest Service mains examination paper that has been conducted recently 2 days back, and this is 2021 paper. So we will see question number 6A. So this is a metal cutting question, orthogonal turning, on which milestone cylinder we have done with HSS single point cutting tool, having rack angle 12 degree. That means alpha naught value is given, with cutting speed is 250 meter per minute. V is given with feed rate 0.15 mm per revolution, that is feed rate. And for orthogonal turning it is initial chip thickness also, and depth of cut is 1.5 mm. So depth of cut is equal to width of the cut for orthogonal turning, and chip thickness ratio is 0.25. R value is given. If the horizontal cutting force is 700 Newton, that means FC, and the vertical force, that is FT, 1250 Newton, that is also given. So determine the following using Merchant's theory. So first of all, shear strain, work done by friction, work done by shear, total work done, and mean shear stress in the shear plane. So before finding all these things, first of all we have to find shear plane angle phi. So we know the formula, tan phi is equal to r cos alpha upon 1 minus r sin alpha. R value we have 0.25 cos 12 degree divided by 1 minus 0.25 sin 12 degree. So when you solve this and take the inverse, so you will find the shear plane angle phi, that is 14.5 degree. Now you can find the shear strain. So first thing that we are going to find is shear strain, that is cot phi plus tan phi minus alpha. Cot 14.5 plus tan 14.5 minus 12. So when you solve this in calculator, you will get shear strain is 3.91 gamma. So this is the first answer that we got. Next thing, work done by friction, that means friction work FW, in short I am going to write, and shear work, that is SW. And total work we can give with the formula shear work plus friction work, that is of total work, and we have to find mean shear stress tau. So what is the formula for the friction work? That is frictional force F and chip velocity, that is VC I am denoting with, and shear work, that is shear force Fs into shear velocity Vs. So we have to find all these four parameters. So what the equation we have? We have a cutting force and thrust force. So the friction force using Merchant theory we can find, that is Ft cos alpha plus Fc sin alpha. The second equation for shear force, that is Fc cos phi minus Ft sin phi. Okay, we have all the value Fc, Ft and alpha. Ft value, that is 1250 Newton, alpha value 12 degree, Fc value 700, and here alpha value again 12, Fc value 700, phi value, that is we already found 14.5 degree, Ft thrust force value 1250 Newton, and when you solve this you will find the friction force F, that is 1368.2 Newton F, and the shear force Fs, that comes out to be 364.73 Newton. Okay, these two. Just keep the as a equation number 1 and equation number 2 as a result. Now we have one relation of velocity using velocity triangle, that is V, that is cutting velocity V divided by sine 90 plus alpha minus phi is equal to Vc, that is cut chip velocity, divided by sine phi is equal to Vs, that is shear velocity, shear plane velocity sine 90 minus alpha. This is the velocity triangle. This triangle I'm talking about, this is cutting velocity, This is shear plane velocity and this is chip velocity Vc. This angle is 90 minus alpha, this angle is phi, and this angle is 90 plus alpha minus phi. So you apply sine rule and you will find this equation. Now we have the value of V 250 meter per minute and the value of alpha and phi, alpha value 12 and phi value 14.5. So here we will get sine 87.5 is equal to Vc divided by sine 14.5 is equal to Vs sine 80 sine 78. So solve this equation simultaneously by comparing with this. So you will get Vc, that is a chip velocity, that is 62.65 meter per minute, and shear plane velocity, that is 244.77. Here there is a point. Sorry. Yes, it is a 244.77 meter per minute. Now we have to find friction work. The second thing, that is friction work, that is frictional force into chip velocity Vc, that is 1368.2 Newton, multiplied by Vc, that is 62.65 meter per minute, but we have to find in kilojoule. So sorry, kilojoule per second, or you can say that kilowatt. So divide by 60. So here you will get 1.428 by using calculator, 1.428 kilowatt. So this is friction work. Third thing that we have to find out, that is shear work. Shear work will be what? Shear force into shear velocity. Shear force is what? 364.73 multiplied by 244.77 divided by 60. Why 60? Because here it is a meter per minute. We have to convert it meter per second. Okay. So here you will get answer in kilowatt, 1.488 kilowatt. The fourth thing that we have to find out, that is total work. Total work is a summation of friction work plus shear work. That is 1.428 plus 1.488. So it will be 2.916 kilowatt. So this is the answer of our second, third, and fourth question. The fifth and last thing that we have to find is shear force. Shear force is what? Fs divided by B into initial thickness T1 multiplied by sine phi. Shear force that we already found out, that is 364.73 multiplied by sine 14.5 divided by width, that is 1.5 mm, and depth of cut is 0.15. Sorry, depth of cut is 1.5 mm and feed rate is 0.15. So when you solve this, you will get 405.88 megapascal. So this is the answer of shear stress, and by this way we have calculated all the values that they required. So this, in such a manner you can solve this and you will get easily 15 marks out of this. Okay, so I hope you like this solution, and in next video we will see a new question solution. Okay, so thank you for watching this video and keep supporting us like this, and a new video on engineering mathematics as well as civil service or forest service, whichever is earliest possible, we will solve first. Okay, so thank you for watching this video and subscribe this channel for more upcoming videos like this.